Welcome. This session we'll talk about GATE 2025 model question, which is question number 37 from the subject structural analysis. Let us see the question. In the rigid jointed frame shown in the figure, the distribution factor of the member AD is closest to. Okay, so which means you need to find the distribution factor of member AD. So there are four members joining at the joint A. You can see the joint A is rigid, given as rigid joint. There are four members, and each member has got various end conditions. You see, end C is free, okay, whereas end B is hinge, and the other ends like D and F are fixed. So for various end conditions, the stiffness values of these members are going to vary. So when you say there is a free end, the stiffness value will be zero. So this is what you have learned from your structural analysis concept. And the stiffness of the member where the end is hinge, okay, is 3 EI by L. If the far end is fixed, the stiffness value is 4 EI by L. Okay, so these are the things which you shall recall while solving such questions. Okay, now let us go for the formula for calculating distribution factor. So stiffness of member AD divided by total stiffness of the joint A is nothing but the distribution factor of member AD. So stiffness of AD, you can see where the end D is fixed. So I can use this formula. But the problem is the member AD, the flexural rigidity is not uniform. Okay, half of the member is having 2 EI as flexural rigidity, and the rest of the half of length is having EI. So it is neither EI nor 2 EI. Okay. So in that case, I'll deal this problem as two cases. First case, I'll take if flexural rigidity is EI. The next case, I'll talk about the same solution with flexural rigidity of member AD as 2 EI. Okay. So in case 1, that means if the entire member AD, if the flexural rigidity is EI, okay, what will be the distribution factor? Okay. So in that case, stiffness of AD will be 4 EI by L. Okay. Next, calculating sigma K value. That is stiffness of AC 0 plus stiffness of AB 3 EI by L plus stiffness of AD 4 EI by L plus stiffness of AF is 4 EI is flexural rigidity is double the value. Okay, so now EI by L common, 3 plus 4 plus 8. Okay, so it is coming around 15 EI by L. Now if I assume this member AD flexural rigidity is EI, what will be the distribution factor is equal to 4 ei by L whole divided by 15 ei by L. So it is 4 by 15 coming around 0.267. Right. Now, case 2, I'll go with second case where if EI of AD is 2EI. Okay, flexural rigidity of the member is twice for the entire member AD. Then K of AD will be 4EI, which means it is twice by L, which is 8EI by L. Now, what will be the total stiffness of the joint? 0 plus 3EI by L. All other member stiffnesses won't change. Only 4 twice EI by L plus again 4 twice EI by L. So which means the total stiffness is coming around EI by L times this is 3 plus 8 plus 8. Okay, that means 19 EI by L. So now the distribution factor of member EAD, if this is assumed as now member with flexural rigidity 2EI. Okay, so where K is 8 EI by L divided by sigma K, total stiffness of the joint. So put together it is 8 by 19. Okay, so the value is 0.421. So what is the actual case for member AD? Half of the member is having flexural rigidity 2EI, the other half is only EI. Okay, so the value of distribution factor shall be minimum 0.267 to maximum 0.421. Okay, so this is the range of distribution factor. So now if you can see what are the values given here. Okay, option A 0.254. So minimum itself 0.267 is not the option. 0.267 not an option because if you want to have 0.267, the member AD shall have EI as flexural rigidity, and 0.398 is in the range of is minimum maximum. Okay, and this is the maximum that it can have if you have 2 EI as flexural rigidity. So your answer is 0.398. Right? Thank you.